Okay, problem number 3.55. Saturated water vapor at 60 degrees centigrade has its temperature, has its pressure decreased to increase the volume by 10%, keeping the temperature constant. What would be the pressure? Should it be at what pressure should it be expanded? So that's a simple one then. So we have got a temperature of the saturated liquid. If you can imagine saturated liquid, which is 60 degrees centigrade, and it would be having at that 60 degrees centigrade, definitely it would be having a saturation pressure. Now the pressure is decreased. Let's say, if I would say like simply in a phase diagram, so we have got a temperature which is 60 degrees centigrade, and that temperature is being constant. So at that temperature we would be having pressure, which is actually the saturation. And let's find out from the steam table what would that pressure would be. So at 60 degrees centigrade temperature, we would be having a pressure of, let's say, sorry for that, we would be having a pressure of 0.019946, which is actually equal to 19.946. So let's go back to this one, and that would be a pressure at 60 degrees centigrade. We would be having a pressure of 19.94 kilopascal. That is in kilopascal. The pressure was written in kilopascal. You say the pressure is reduced. So when the pressure inside the vapor dome, we have got as it was saturation. But inside the vapor dome, we cannot reduce the pressure while keeping the temperature constant. So what we have to do, if we want to reduce the pressure, we have to go through in a superheated region. So in a superheated region, obviously, we will be going, and then the pressure will be reduced. So what it say like till what? So it would be reduced till when the volume is increased by 10%. So in other words, if I say like this is my volume Vg somewhere here. So when the volume of the water is in increased by 10%, which is equal to 110% of Vg, what would be the pressure at this point? That would be what would be the pressure P2. If I'm saying like this is P1, so what would be the pressure P2? So in other words, what I'm saying like it would be a pressure P1, a pressure P2, and then obviously looking at the steam table. So let's first thing first, let's find the different volumes now. So in our steam table, if I'm saying like at a temperature of 60 degrees centigrade, I would be having a volume which is actually equal to Vg, which will be equal to 7.6677. That's what actually it is written. Um, if I'm reducing the pressure, sorry, if I'm reducing the pressure by increasing the volume, and that volume is increased by 10%, so that means 10% of this volume. So that means 10% would be added to this volume. So multiply with 1.1, which is 110%. So the volume would become 8.4378. So in other words, at this pressure, sorry, at this volume, what would be the pressure? So let's go back to the superheated table. And superheated table, we have to find out the temperature, which is actually at 60 degrees centigrade, and volume, which is actually equal to 8.4378. If you go look at the different steam uh, steam table actually, so it will be definitely very difficult to find the temperature is actually equal to 60 degrees centigrade. So let's have a different point of view now, and different point of view would be rather than actually looking at the temperature, we should look at the pressure now. So what I'm saying now that it's a like pressure would be reduced. In other words, let me draw this thing over here. and that is actually at 60 degrees centigrade, pressure is at the initial pressure is P is equal to 19.94, 19.94 with a volume of 7.6707. The pressure is reduced, I increase the volume. So let me say like this is reducing pressure, this direction, so increasing the volume. So when the volume is increased by 8.4378, what would be the pressure, which is actually over here. So in other words, what I mean to say, like I would reduce the pressure further to find another point, which would be this point, and to find this volume, which would be this volume, and interpolate between them, this volume and this volume, for this pressure and this pressure to find the pressure P over here. So let's move to superheated table right now again. So in a superheated table, if you can look at different value, so you have got a value of 0.02, which is actually equal to 20 kilopascal. So your own pressure is 19.94. So definitely we are looking for the pressure which would be less than 19.94. So over here we have got a pressure of 10 kilopascal. At 10 kilopascal, we have to find the volume which would be corresponding to 60 degrees centigrade. And let's assume for a while we have got a temperature at 60 degrees centigrade. Why I'm saying like let's assume for a while, I would explain it a little bit later. So that means like at 10 kilopascal, I should have a volume which is somewhere here given, which is 15.3345. It's given, not given. You need to find out, but that's what actually for simplicity I'm saying like it is actually 15.3345. So now it must be very easy now to interpolate between the value of volume this much, pressure this one, to find the pressure which is actually equal to find the pressure which is actually equal to for equal volume of this one. What's a little bit trick about this question is um, I did say like let's assume that we know the pressure at 10, we know the volume at 10 pascal at a temperature of 60 degrees. But if you can look at the steam table itself, we do not have got a column of 60 degrees centigrade at 10 kilopascal. So what my point of view would be, first you have to, on a rough side or whatever what you call it, first you have to find a volume at 60 degrees centigrade, obviously by interpolation between them two value. Once you find the volume which was equal to 15 point something, once you find that volume, you have to put up in this, I would say, and then find the pressure at this one, which is equal to 18.9 kilopascal. I hope you understand. Let's have a little practice, and if you still have got problem, then obviously we will discuss it. So let's move to another example, example 4.2. This is example from Rainer Joule book, Engineering Thermodynamics. Well, let's say it's not relevant over here, but the example is relevant. Till now, we have done a method which is called as the slope method, which was easy for you people because you were already familiar with the slope method. Let's have another method. This is called as the tabular method. Sometimes some people find this tabular method a little bit easy, while some people would still stick to their old method, which is actually the um, slope method. Let's see why I'm interested in the tabular method, and I will explain it at the end. Let's have a question then. First, determine the saturation temperature, specific enthalpy of specific liquid enthalpy, which is HF, specific enthalpy of evaporation, which is HF, HFG, and specific enthalpy of dry saturated steam, which is equal to Hg. We do not actually, you do not need to remember this right now because we will be doing it after first of thermodynamics. So determine these four property at a pressure of 2.04. So whatever steam table you are looking at, whether it is a compact addition or whatever it is, the value of 2.04 would be definitely not there. Why I'm saying, like, either you would be having a value of 2.0 or either you will be having a value of 2.1. So it would be very unlikely that you would be having a value of 2.04. As you can imagine, that's why it is called as the compact addition of our steam table. So at a value of 2.1 and a value of 2.0, we would be having a value of temperature. If I can imagine, so let's say at a value of 2.1, we have got a temperature of 214.9. A value of 2.0, we will be having a temperature of 212.4. And let me write it down somewhere here. 2.0 is 212.4. So 2.4 at a value of 2.1, we will be having a value of 214.9, and we are interested in a value of 2.04. That is the value of temperature over. We need to find out this one. So in other words, if you can look at the graph itself, if you can look at the slope graph itself, so you can imagine that, and so whatever the distance between them, it will be having the same percentage of distance between whatever the distance between them two values. It is actually having a same value over here. That's why it's a little bit, what if you can imagine, it's what we can imagine is, we call it as a linear interpolation. um Sorry, so that's why it's called a linear interpolation. Linear interpolation mean like we will be having a value which will be actually linearly moving. So in this tabular method, that's a very simple one. um, if I can imagine, like, what's the difference between them two values, that is equal to 0.1. Difference between this value and this value is 0.1, and the difference between this value and this value is 0.4, is something 0.04, sorry for that, 0.04. So what would be the percentage difference, what would be the percentage of this space somewhere here? That mean like the percentage would be equal to, if I would just simply say, percentage will be equal to 0.04 divided by 0.1. That's how you find the percentage between them. So this is the percentage of this one. So if you can imagine, this is the same percentage what we would be expecting somewhere here. So that means like, this is, if I find this percentage which is already there and multiply this percentage over this difference, which roughly, or which is equal to plus 2.5. I'll say like, if I multiply this percentage, which is 0.04 divided by 0.1, multiply this percentage with 2.5 actually, so it will give me a value which is, if I imagine, which is equal to 1.0. So it will give me a value which would be equal to 1.0 over here, or which will be the value of this portion. So now, so if what I'm saying now is, at this point the value is 2.2.212.4, this portion is equal to 1.0. So that means like, at this point the value is 213.4. Also, if I would just say like, this is the value of this percentage. Now if I'm saying like, I need to find out the value of this one, so that would be simply equal to 214.4. If I just need a value of this one, So that mean like it will be something again different to 1 4.9. If you can imagine, that was equal to zero point 0.5, adding zero point 0.5 to it. So that's a simple one. So you can imagine what actually these are. This value, this is the percentage value. Multiply this percentage value with the difference, and you will find the value itself. And then value itself would be added to this one. So this is what we call it as a tabular method. And let me show the tabular method now to you. So that means like we have got this value 214.9. The total difference is 2.5. The actual difference, the difference between them is the total difference between them. The pressure is 0.1. The required is 0.4. So the percentage required is 0.4 divided by 0.1. This is the percentage. Multiply by the difference. You will get the value and add the value to this, not this one, sorry. Add the value to this one. You will find the value, which is 213.4. Now, as some people would find it a little bit tricky or a little bit difficult, but why I'm saying like it would be actually a little bit useful to you people, because then you do not need to find out the other value using the slope method. You find out the value of enthalpy at 2.1, enthalpy at 2.0, find the difference, multiply that difference with percentage, you will find the value, add that value to this one, and you will find the actual thing. Similar thing, HFG, multiply with the percentage, getting the value, adding this one, you will find the other value, and so on and so forth for the other value as well. So obviously, if you are looking for the enthalpy, then you are looking for the entropy, or you are looking for the internal energy. So obviously, if it is so many values you are looking for, the slope method would be a little bit difficult, and not difficult in itself, but it would be a little bit, I would say, like time consuming for you people. So it is much better that if you find the a tabular method, and tabular method is easy if you have got a multiple answer to get. I hope you understand that one. I hope if there is any problem, we can have a class, arrange class for the question and answer session. So have a nice time.